The electronics and design of the control box is very basic, but would need to be designed properly by an electronics expert or someone who knows what they are doing. There are two power inputs into the control box, one from the battery and one that feeds from the main generator output. The battery power is used to start the drive and bring it up to running speed. Once the generator is running, 24 volts is fed to the control box from the generator output and can be manually switched over from battery power to generator power. Each of the battery and generator inputs has an on-off switch, and a voltage for each can be controlled with a potentiometer adjustment knob, and the output to the electromagnets monitored via a VA meter for each. Here's the startup and control sequence. Ideally, switching between power input sources should be automatically controlled with appropriate circuitry, which switches over depending on the power output of the main generator. The wires used in the active wheel should be EM shielded wire and routed so as to maintain the symmetry and balance of the drive wheel. The parts and assemblies have holes and roots where required to facilitate the wiring. I've heard that using silver connectors for joining wires significantly reduce the losses caused by wire connections and joins, but may not be necessary in this design unless too much electrical loss is observed through various connections. The required monitoring of the drive and generators are the RPM of the main drive wheels and component temperatures. Other monitoring of the first prototypes is highly recommended to ensure smooth and safe operating parameters. You can use simple battery-powered laser RPM meters to monitor the RPM of the main drive wheels, diff wheel bearings, and their axles. Simple battery-powered laser temperature probes are used to monitor the temperatures of the electromagnets, electromagnet contacts, and other components. It's my current understanding that the electromagnets, contacts, and components should run quite cool. If high temperatures are recorded, this would be due to the design and operating parameters of the electromagnets and contacts in conjunction with how much voltage is supplied to the electromagnets. Specialist equipment should be used to establish two things. Firstly, the presence, frequency, and intensity of any background electrical and radio frequencies in the location where the generator is while it's powered off. This is important because it's possible that external signals may interfere with the smooth running of the generator drive, and should be in a relatively clean and shielded environment to eliminate these external factors for testing purposes. And secondly, any signal interference that may be produced by the running generator. In the event that the drive causes electrical or radio signal interference, appropriate shielding and or cancellation frequencies can be applied to solve the problem. The generators and their main drive wheels should be well balanced to prevent excessive vibration, which would cause components to wear out faster and the drive to run less efficiently. Vibration also causes unwanted noise. The appropriate balancing and vibrating monitoring equipment should be used to determine this. In this exploded assembly view, you can see the drive wheels have bolt covers also to smooth out the airflow around the spinning wheel, to reduce air resistance and improve its efficiency and performance, but the bolt covers aren't essential. Here's the assembled active wheel. The bolt covers are semi-transparent in this view, and they can be made of heat-resistant plastic, although I don't expect that the drive wheels will get very hot. I've designed an alternative configuration where the passive wheel can be assembled with only 2 contacts instead of 4 and a different switch magnet arrangement. The active wheel doesn't need any changes. The only additional parts required are 2 blockers made of the same material as the drive wheel, which replace 2 of the magnet contacts, and 2 different switch magnet spaces. The mount ring for the switch magnets already has the required threaded holes to accommodate the assemblies for both versions. Similar to the previous switching sequence animation, this is the switching sequence of the version 2 alternative assembly. The advantage of this arrangement is that the reed switches and electromagnets turn on and off half the number of times per revolution of the main drive wheel, and, as a result, generate less heat from the on-off switching on the electromagnets, and the main drive could potentially run at a higher maximum speed. The disadvantage of this arrangement is that it produces only about half the amount of torque as the version with 4 contacts, because there are half the number of magnetic attractions which start from a further distance between the electromagnets and the approaching contacts. So the reason I focused on the version 4 design is to ensure maximum torque from the drive to be able to turn the alternator generator axles at the required speed. The current drive designs are electromagnetic pull-only type drive. Since they are driven by only magnetic attraction of opposite magnetic pole charges and does not use magnetic repulsion, the magnetic attraction causes the magnet and its opposing contact to pull towards each other, which produce the drive motion. The current electromagnet contacts are plain soft iron and not magnets, and so would be attracted to both or either the positive and negative pole of a magnet or electromagnet. A push-only type of electromagnetic drive would use electromagnetic repulsion between two like poles. This would require the electromagnet contact to be a magnet so that it has a fixed charge pole for the electromagnets to repulse against. The electromagnet fires just after the contact has passed by, pushing it away. A pull-push type EM drive uses both magnetic attraction and magnetic repulsion. For this method to work, the electromagnet contact would have to be a magnet so that it has a fixed charge or pole for the electromagnet to repulse against. First, the electromagnets pull towards the contact with opposite poles, and then, after passing by, reverse the electromagnet polarity in the electromagnet, causing it to repulse the contact because of the like poles. It is possible to convert the current drive into a pull-push type of EM drive if you use fairly weak natural magnets for the magnet contacts in the passive wheel, mounted with their polarities all facing the same way. Then, if you add another 3 reed switches to the switching section and wire appropriately so that each pair of electromagnets has 2 reed switches instead of only 1. The first switch would feed current to the electromagnets in one direction to pull the contact towards the electromagnet. Then, just after the electromagnet and contact pass each other, the second reed switch would activate to feed current to the electromagnets in the opposite direction, causing the contact and the electromagnet to push away from each other. This pull-push method is potentially much more powerful, but would also double the power consumption of the drive, since the electromagnets are fired twice per pass-by instead of just once. It would also increase the electromagnet and contact temperatures, and using natural magnets for the contacts would also cause additional resistance to the drive from the permanent magnetic fields. High-frequency sound can be directed at the main drive wheels to affect the intensity of the reaction between the electromagnets and their contacts. Some frequencies will enhance the reaction, and other frequencies will inhibit the reactions, and could even render the generator inoperable. For a long time, my main hobby has been working on finding possible alternative ways to generate clean and free electricity. I'm not a scientist, nor am I trained in any electronics, engineering, design, or sciences. Instead, I've used basic science and physics principles with creative and logical thinking and a lot of research. I hope that I've explained the workings of this electromagnetic differential drive clearly and in simple terms that anyone should be able to understand. I would love to hear from you if you have any feedback on how to further optimize the design to make it more cost-effective and efficient so it can benefit a wider population. It is my dream for all of us to have access to clean and free electricity. A few years ago I released a video explaining some of these concepts and related general information. I encourage you to watch that if you're interested in finding more about those ideas, my motivation and journey of discovery. I also present compelling evidence to show that what I'm trying to achieve is not only possible, but similar things have been successfully done before. You can email me if you have any questions or interest in this work. Thank you for watching, and please do share or reproduce this information. I sincerely hope that it will be someday of benefit to us all.